Welcome to the discussion. Today we're diving into a fascinating paper about using large language models, LLMs, to create a network of collaborating agents. The paper proposes a dynamic system, meaning the team of agents and how they communicate changes depending on the task. What initially drew your attention to this research?
The core idea is really intriguing. Building a system that automatically assembles the best star team of LLMs for a given job, rather than relying on predefined, static teams. This mirrors how human teams work. We don't use the same group of people for every project. The potential for efficiency and improved performance is significant.
That's a great point. The paper introduces a framework called Dylan. Can you explain the two-stage process it uses?
Dylan works in two stages: team optimization and task solving. In the first stage, it runs a preliminary trial with all the available agents. It then uses a metric called Agent Importance Score to figure out which agents contributed the most. These top performers form the team for the second stage.
So it's like a tryout before the main event. How does the agent importance score actually work?
It's a clever, unsupervised method. The agent's responses are essentially peer-reviewed. Each agent rates the responses of the agents that came before it. These ratings are then propagated backward through the network, kind of like backpropagation in neural networks, to calculate each agent's overall importance.
That sounds quite sophisticated. And what happens in the task solving stage?
In this stage, the selected agents collaborate dynamically. They communicate in a structure that resembles a temporal feed-forward network. A LLM ranker monitors their performance and can even remove underperforming agents during the process, adapting the communication structure on the fly.
This dynamic adjustment sounds key to its success. What kinds of tasks did they test Dylan on?
They tested it on a variety of tasks: code generation, decision-making, general reasoning, and arithmetic reasoning. Across the board, Dylan outperformed existing methods, often with significantly fewer API calls, a measure of computational cost.
That's impressive. Were there any particular areas where Dylan excelled?
In general reasoning tasks, using Dylan's team optimization improved accuracy by up to 25%. This highlights the real power of tailoring the agent team to the specific problem.
That's a substantial improvement. What about the limitations of the approach? Are there any potential downsides?
One limitation is that the performance depends on the quality of the initial set of agents. If most agents are poorly designed or trained, the system won't perform well, even with optimization. Also, while the early stopping mechanism improves efficiency, it's not always perfectly effective, especially for open-ended tasks like code generation.
So it's not a silver bullet, but it shows a lot of promise. What are some of the next steps for this research?
The authors plan to explore Dylan's performance with open source LLMs, making it more accessible and potentially reducing costs. They also want to investigate more sophisticated optimization techniques to further improve efficiency and performance.
It's exciting to see this research pushing the boundaries of LLM-based agent collaboration. The idea of dynamically assembling teams based on performance is a significant step forward. What are your overall thoughts on the implications of this work?
I think this work is a significant contribution to the field. It demonstrates the potential of dynamic agent teams for solving complex tasks more efficiently and effectively. The unsupervised agent selection method is particularly innovative and could have broader applications beyond LLMs. The ability to adapt to different tasks and domains is a major advantage.
It certainly opens up many avenues for future research. The potential applications across various fields are vast. What are some of the ethical considerations that come to mind when thinking about this type of technology?
The ethical considerations are crucial. Since LLMs can sometimes generate biased or harmful outputs, it's important to carefully consider how Dylan might be used and the potential for misuse. Robust safety mechanisms and careful monitoring are essential to mitigate these risks. Furthermore, the transparency and explainability of the agent importance score are important for building trust and understanding.
Absolutely. Transparency and accountability are paramount. This discussion has been incredibly insightful. Thank you for sharing your expertise on this cutting-edge research.
My pleasure. It's a fascinating area, and I'm excited to see where it goes next.
And thank you to our listeners for joining us. We hope you found this discussion informative and engaging. Until next time.